The complex interaction between building environment and people behaviors can be accurately evaluated by means of dynamic simulation tools. Many of them are available on the market, but there are also some ones developed by universities or research laboratories downloadable for free, which are completely reliable. In fact, DOE2 and Energy Plus are the engine of most commercial products. DOE 2.1e predicts the hourly energy use and energy cost of a building. Designers can vary building parameters that improve energy efficiency while maintaining thermal comfort and cost effectiveness. DOE 2.1e has 4 simulation subprograms: loads, systems, plant, and economics, which are executed in sequence. So, the output of one module becomes the input of the following one. Each simulation subprogram also produces printed reports of its results. Before running them, the building description language processor reads input data and calculates a response factor for the transient heat flow in walls and weighting factors for the thermal response of building spaces. Many interfaces have been developed to make the program easy to use. One of them is eCast, an easy-to-use building energy analysis tool that provides professional-level results with an affordable level of effort. This is accomplished by combining a building creation wizard, an energy efficiency measure wizard, and a graphical results display module with an enhanced DOE 2.2 derived building energy simulation program. Its building creation wizard involves following a series of steps that helps to describe the features of the design that would impact energy use, such as architectural design, HVAC equipment, building type and size, floor plan and layout, construction material, area usage and occupancy, and the lighting system. eCast offers several graphical formats for viewing simulation results. It allows one to perform multiple simulations and view alternative results in side-by-side graphics. It offers features like energy cost estimating, daylighting and lighting system control, and automatic implementation of common energy efficiency measured by selecting preferred ones from a list. Energy Plus is a modular structured software tool based on the most popular features and capabilities of BLAST and DOE 2.1e. It is primarily a simulation engine. Input and output are simple text files. Energy Plus grew out of a perceived need to provide an integrated and simultaneous load and system simulation for accurate plant and system sizing and comfort prediction. Loads, calculated at the user-specified time step, are passed to the building system simulation module at the same time step. The Energy Plus building simulation module calculates the heating and cooling system and plant and electrical system response. This integrated solution provides a more accurate space temperature prediction. Also, it allows users to evaluate realistic system controls, moisture absorption and desorption in building elements, radiant heating and cooling system, and interzone airflow. Energy Plus has 2 basic components: a heat and mass balance simulation module and a building system simulation module. The heat balance module manages the surface and air heat balance and acts as an interface between the heat balance and the building system simulation manager. Since Energy Plus is only a simulation engine that requires a text input data file, some user interfaces are necessary. OpenStudio is one free plugin for SketchUp that allows users to build the model geometry and to specify corresponding envelope components by using intuitive SketchUp drawing tools and interfaces. Furthermore, it allows the main characteristics of thermal zones like occupancy, ventilation rates, internal heat gains and set point temperatures to be set. Best Energy is also a SketchUp-based tool and was developed starting from the 1.08 version of OpenStudio, with respect to which some specific modules were implemented in order to make the modeling of some specific Energy Plus objects more affordable and to better manage and design some architectural components. It also supports decisions on strategic aspects of architectural design that can highly improve building energy performance even in preliminary phases. For instance, it implements specific interface modules for definition of schedules, evaluation of occupant comfort, opaque and transparent constructions, solar shading devices, and airflow due to natural ventilation. Symergy is a very suitable software to model plant systems using Energy Plus objects by an interface that allows the user to drag and drop blocks and components in a graphical scheme. Here, characteristics of the single item can be edited. By the way, its capabilities in modeling geometric and zone properties are not very intuitive. It deals with BIM interoperability issues since it can manage IFC files. Such file format was derived by an international standard developed in order to define all parameters and components in a building needed for each design stage and in its operation, as in industrial design. In this way, building models generated by different software, also for specialist analysis, can be imported without losing specific information. Experts, as architects, structural engineers, HVAC designers, and so on, can work on a common shared model. Radiance is the most powerful and reliable software intended to aid lighting designers and architects in predicting lighting levels and visual appearance of a space prior to construction. It can also be used by researchers to evaluate new lighting and daylighting technologies and to study visual comfort. Unfortunately, it lacks a graphical user interface to model the scene in an easy way, so a third-party tool should be used. It calculates spectral radiance values, illuminance and color, for interior and exterior spaces considering electric lighting, daylight and interreflection. The major portion of the Radiance package is the lighting simulation engine that calculates light levels and renders images by using backward ray tracing technique, which consists in starting from a measurement point and tracing rays of light backwards to the source. Output consists of luminance and illuminance values and appearance to the eye of the lit space, and they can be plotted in tables or imported in calculation grids by other graphical interfaces. Also, it can provide photograph quality images and video animations. DaySim is a validated Radiance-based daylighting analysis software that models the annual amount of daylighting in and around buildings. It allows users to model dynamic facade systems ranging from standard Venetian blinds to state-of-the-art light redirecting elements, switchable glazing, and combinations thereof. Users may further specify complex electric lighting system and controls, including manual lighting switches, occupancy sensors, and photocell-controlled dimming. Simulation outputs range from climate-based daylighting metrics, such as daylight autonomy and useful daylight illuminance, to annual glare and electric lighting energy use. DaySim also generates hourly schedules for occupancy, electric lighting loads, and shading device status, which can be directly coupled with thermal simulation engines such as Energy Plus, eCast, and Transys. Even if it seems to couple an intuitive 3D modeling interface with extensive solar, thermal, lighting, acoustic, and cost analysis functions in a comprehensive and simple way, Ecotect can't provide a reliable numeric simulation of those items. It is very useful for a realistic and expressive shading analysis and for building models to be processed into Energy Plus, with many limitations, Radiance and ASIM, and it can import and show their output in a calculation grid that makes results easy to understand. In conclusion, many powerful tools helping designers in dealing with energy issues in buildings are available. By the way, users should have a good knowledge of software features, limits and modeling process. Also, a general idea on expected result should be kept in mind to avoid gross errors.